The world's most powerful dam holds back 39.3 billion cubic meters of water. That's enough to flood entire countries, enough to reshape coastlines, enough to end millions of lives in a single night. China's Three Gorges Dam stretches 2,309 meters across the Yangtze River, the longest river in Asia, the third longest on Earth. Behind it sits a reservoir that reaches 600 kilometers inland, a body of water so massive that NASA calculated its weight actually slows the rotation of the planet by 0.06 microseconds per day. This is the largest power station ever built. 32 main turbines generate 22,500 megawatts of electricity. A wall of concrete 185 meters tall, holding back a force that never stops pushing. For decades, Beijing called it the crown jewel of Chinese engineering, proof that the party could bend nature itself. But nature has a long memory, and the cracks, both literal and structural, are spreading. The sediment is building, the earthquakes are increasing, the margins are shrinking, and the economic heartland it was built to protect now depends entirely on a single wall that was never designed to last forever. The world's most powerful dam isn't just infrastructure, it's a loaded weapon, and what was built to protect China may become the force that destroys it. To understand how China ended up here, holding a nation's future hostage behind a wall of concrete, you have to go back to the beginning, to a dream that was always as much about politics as it was about engineering. The dream started over a century ago. In 1919, Sun Yat-sen, the father of modern China, first proposed damming the Yangtze to tame its deadly floods and generate power for a nation that was still reeling from centuries of imperial collapse. It was visionary. It was also impossible, at least at the time. Mao revived the idea in the 1950s after catastrophic floods killed over 30,000 people across the Yangtze in 1954. The floodwaters submerged Wuhan, a city of 8 million, for over 3 months. The Jingguang Railway, one of China's most critical transport arteries, was knocked out for more than 100 days. Soviet engineers were brought in. Plans were drawn up, but political chaos, the Great Leap Forward, the Cultural Revolution, it all kept pushing the project into the future. For decades, the dam existed only as a blueprint and a political football, revived whenever leaders needed a symbol of national ambition, shelved whenever reality intervened. It wasn't until 1992 that the Chinese government finally put it to a vote, and what happened next was extraordinary. In a political system built on unanimity, 177 delegates voted against the dam. Another 664 abstained. Nearly one-third of the National People's Congress, an institution designed to rubber stamp the party's decisions, refused to endorse the project. It was the largest act of legislative dissent in the history of the People's Republic. Engineers warned about seismic risks. Ecologists warned about extinction cascades. Hydrologists warned the design would underestimate the Yangtze's fury. They were overruled. Premier Li Peng, a Soviet-trained engineer with deep personal investment in the project, pushed it through. The dam would be built, the dissenters would be silenced, and within 2 years, the most ambitious construction project in Chinese history was now underway. Construction began in 1994. Over the next 12 years, workers would pour 28 million cubic meters of concrete into a gorge that had carved itself over millennia. They built the largest hydroelectric structure on Earth, bigger than Itaipu in Brazil, bigger than anything that the world had ever attempted. The reservoir flooded over 630 square kilometers of land. 13 cities, 140 towns. They all vanished beneath the waterline. More than 1.3 million people were uprooted from the only homes they'd ever known, forced to rebuild their lives on higher ground, often without adequate compensation. Entire communities that had existed for centuries were erased from the map. Archaeological sites dating back thousands of years were submerged before they could be fully evacuated. The human cost was staggering, not just in numbers, but in the erasure of identity, history, and belonging. And in the process, they turned a living river into a regulated machine. But the price wasn't just political, it was biological. The Yangtze wasn't just a river, it was an ecosystem that had evolved over millions of years, one of the most biodiverse freshwater systems on the entire planet. The dam didn't just disrupt it, it killed it. The Baiji, the Yangtze River dolphin, had survived for 20 million years. It outlasted ice ages, continental shifts, and the rise and fall of entire civilizations. But in 2006, an international team of scientists conducted a 6-week expedition across the full length of the Yangtze to find a single surviving individual. They searched 3,400 kilometers of river, and they found nothing. The Banqiao was declared functionally extinct, the first large vertebrate driven to extinction by human infrastructure in modern history. But the Banqiao wasn't alone. The Chinese paddlefish, a species that predated the dinosaurs, sometimes growing to 7 meters in length, was formally assessed as extinct in 2020. The Yangtze sturgeon, once thriving in the tens of thousands, collapsed to near zero wild populations. The Chinese alligator retreated to a handful of shrinking habitats. The river's entire food web didn't just weaken, it unraveled, link by link. And the damage extended far beyond individual species. The dam blocked migration routes that fish had followed for millennia. Spawning grounds were severed from feeding habitats. Downstream water temperature shifted because the reservoir released water from different depths than the natural river. The entire biological rhythm of the Yangtze, seasonal floods, sediment pulses, temperature cycles that every organism depended on, was rewritten by engineers in a control room. And then there's the sediment. Before the dam, the Yangtze carried roughly 500 million tons of silt downstream every year. That sediment fed the delta, replenished wetlands, and sustained agriculture across a region that feeds hundreds of millions of people. But now, the dam traps the vast majority of it. The downstream delta is eroding. Saltwater intrusion is creeping inland. Poyang Lake, China's largest freshwater lake and a critical stop on migratory bird routes across East Asia, has experienced repeated severe low water crises. Satellite imagery shows it shrinking to a fraction of its normal surface area during dry seasons, exposing vast stretches of cracked lake bed where water once sat meters deep. The river's heartbeat was replaced by a mechanical pulse, and what the dam gave China in control, it took from everything downstream. But what you've seen so far is just environmental damage. What comes next is structural. If you've been learning something on this deep dive, subscribe now, because the next section explains why this isn't just about ecology, it's about national survival. When you fill a valley with 39 billion cubic meters of water, the valley will push back. Within years of the reservoir's first filling, seismologists began recording thousands of small earthquakes in the surrounding region, a phenomenon known as reservoir-induced seismicity. The sheer mass of water pressing down on geological faults that had been stable for centuries began triggering tremors the area had never experienced before. The 2008 Sichuan earthquake, which killed nearly 70,000 people, struck just 500 kilometers from the dam. While the direct link remains debated among scientists, the proximity raised uncomfortable questions about whether the massive redistribution of water weight was destabilizing geology far beyond the reservoir's immediate banks. Studies also linked the sharp uptick in seismic activity directly to the filling and drawdown cycles of the reservoir. But the earthquakes weren't the only warning sign. Landslides, massive ones, began occurring along the reservoir's 600-kilometer shoreline. In May 2009 alone, between 20,000 and 50,000 cubic meters of rock plunged into the flooded Wuxiao Gorge of the Wu River. In the first 4 months of 2010, authorities documented 97 significant landslides. The valley walls, subjected to constant cycles of rising and falling water levels, sometimes fluctuated by 30 meters between seasons, and they were slowly destabilizing. Each cycle loosened the geology a little bit more. Each year, the slopes weakened. Engineers estimated that the reservoir's banks contained over 5,300 dangerous sites, places where the rocks could give way without warning, sending walls of debris crashing into the water below and generating waves that could overtop sections of the dam itself. INSAR satellite monitoring, the same technology used to track tectonic plate movement, detected measurable deformation along the reservoir's banks. The ground was literally shifting under the weight of what China had built. And then came 2020. During the worst monsoon season in decades, 5 consecutive flood waves slammed into the dam between June and August. The Yangtze Basin received its highest precipitation since 1961. Rivers and lakes across southern China would swell past their floodlines. Over 63 million people were affected. At the peak, floodwater poured into the reservoir at 75,000 cubic meters per second, the highest inflow since construction. The water level surged to 167.65 meters, just 7.35 meters below the dam's absolute maximum of 175, less than 8 meters between containment and catastrophe. To prevent a breach, operators opened the floodgates and deliberately released massive volumes of water downstream, pushing outflow to 49,400 cubic meters per second. They were causing the very flooding the dam was built to prevent. They had to create a flood to stop a worse one, and downstream hundreds of millions of people braced for impact. And even then, the margins were razor thin. The dam did hold, but the message was clear. In a bad enough year, it may not. That year, the dam's operators publicly admitted to what they called slight deformation in peripheral sections of the structure. Social media across China erupted with speculation. The government scrambled to reassure the public, insisting the deformation was within design parameters, insisting the structure remained sound. But the admission itself was unprecedented. In a system that never shows weakness, the cracks were becoming impossible to hide. But geology isn't the real vulnerability. The real vulnerability is what this dam holds together. The Yangtze River doesn't just flow through China. It's the economic spine of modern China. The Yangtze River economic belt spans 11 provinces and municipalities, from Chongqing in the mountainous west to Shanghai at the river's mouth on the East China Sea. As of 2024, the single corridor accounts for 47.3% of China's entire GDP, and that number has been climbing, up from 42% just a decade ago. Nearly half of the economic output of the world's second largest economy flows through, alongside, or depends on one river system. This is the world's busiest inland waterway. Over 4 billion tons of cargo move along the Yangtze every year, more than the Mississippi, the Rhine, and the Danube combined. Shanghai's port, sitting at the downstream end of this corridor, handles more containers than any port on Earth. Over 50 million units in a single year. The factories, refineries, power plants, and logistics networks that line the Yangtze produce everything from semiconductors to steel, pharmaceuticals to consumer electronics. Wuhan, Nanjing, Chongqing, megacities of 10 million or more people each, all sit along the Yangtze corridor. The automotive industry, the chemical sector, rare earth processing, agricultural heartlands producing a third of China's grain, all threaded along this single river system like beads on a string. And here's the part that should stop you cold. Despite being the largest power station on Earth, the Three Gorges Dam now supplies less than 1% of China's total electricity demand. The country's energy appetite has grown so explosively that the dam's 22,500 megawatts, once considered world-changing, barely register on the national grid. So what is the dam actually for? Flood control, navigation, keeping the economic heartland stable enough to function. The dam's real value isn't the electricity that it generates, it's the catastrophe that it's supposed to prevent. A single piece of infrastructure holding together an economic corridor worth tens of trillions of yuan. If the river would flood uncontrolled, the losses wouldn't be measured in billions. They'd be measured in percentage points of global GDP. Every container ship waiting to dock in Shanghai, every factory in Wuhan drawing cooler water from the Yangtze, every rice paddy in Jiangxi irrigated by its tributaries, all of it depending on a river system that's regulated by one dam. That's not strength. That's a single point of failure. And the most dangerous failure isn't a breach, it's a narrowing margin. Every year, the dam ages. Every monsoon season, sediment accumulates behind the wall, slowly reducing the reservoir's flood storage capacity and increasing pressure on the structure. Turbine blades erode from grit-laden water. Concrete degrades under decades of cyclic thermal and hydraulic stress. And climate change is intensifying rainfall across the Yangtze basin, producing the kind of extreme weather events the dam was never designed to handle at this frequency. What was once a century-level event is becoming a decade-level reality. The margins aren't collapsing overnight. They're tightening, slowly, steadily, irreversibly. And China has been here before. In August of 1975, Typhoon Nina stalled over Henan province and dropped a year's worth of rain in 24 hours. Over 1,000 millimeters fell in 3 days. The Banqiao Dam, designed to withstand a once-in-a-thousand-year flood, faced a once-in-2,000-year event. Communication lines went down. Upstream gauges went dark. And just after 1 a.m. on August 8th, the dam gave way. A wall of water 7 meters high and 10 kilometers wide tore across the flatlands at 50 kilometers an hour. It shredded villages while people slept. 62 dams failed in a chain reaction, one after another, like dominoes. Roads, bridges, railway lines, they were all obliterated across an area the size of Connecticut. The official death toll was 26,000. Independent estimates, including from 8 senior members of the Chinese People's Political Consultative Conference, put the number at 230,000, because most didn't die from the initial flood. They died from what came after. Communication with the outside world was destroyed. Over 10 million people were stranded in contaminated floodwater with no food, no clean water, and no way out. Relief teams couldn't reach the worst-hit areas for 2 weeks. Airdrop supplies would miss their targets and rot in the water. Famine and epidemics swept through the survivors for months. The Chinese government classified the entire disaster as a state secret. The full details weren't declassified until 2005, 30 years later. Built by the same system, managed with the same opacity, defended with the same assurances that the engineering was sound. Now scale that logic to the Yangtze. A catastrophic failure at Three Gorges wouldn't just flood farmland. It would paralyze the economic corridor that produces nearly half of China's GDP. Power grids would cascade into a blackout across multiple provinces. Ports would shut down. Supply chains that feed global manufacturing, from iPhones to industrial chemicals, would seize overnight. The downstream devastation would reach all the way to Shanghai, a city of 29 million people sitting at sea level at the mouth of the Yangtze. Global insurance markets would face claims on a scale that had never been seen before. International shipping routes that depend on Chinese exports would grind to a halt. This isn't prediction. This is consequence analysis. And the consequences, well, they don't require a full breach. Even a partial failure, a controlled emergency release like 2020, but larger, could trigger economic shockwaves felt on every continent. And you'd think, after all this, China would stop building megadams. But they didn't. They doubled down. In July of 2025, China broke ground on the Midog Dam, a hydroelectric megaproject on the Yarlung Tsangpo River in southeast Tibet. When completed, it will be the most powerful dam ever built on Earth by a staggering margin. 60 gigawatts of installed capacity, triple the Three Gorges, an estimated cost between $137 and $168 billion, making it the single most expensive infrastructure project in human history, designed to produce 300 billion kilowatt hours of electricity annually, enough to power nearly 300 million people. Beijing has framed it as essential for the country's green energy transition and for powering the explosion of AI data centers across China. The project was approved in December of 2024 and broke ground barely 7 months later, a pace that alarmed engineers and geologists who argued that the environmental and seismic site studies were dangerously incomplete, and they're building it in the most dangerous terrain imaginable. The Yarlung Tsangpo carves through the Himalayas and the Great Bend, a geological wonder where the river plunges nearly 3,000 meters in elevation over just a few hundred kilometers. This is one of the most seismically active zones on the planet. The region sits directly on the collision boundary between the Indian and Eurasian tectonic plates, the same forces that built the Himalayas and continue to push them higher every year. Major earthquakes are not a risk here, they're a certainty. The dam site sits roughly 30 kilometers from the Indian border, and downstream, the Yarlung Tsangpo becomes the Brahmaputra, the lifeline for hundreds of millions across northeastern India and Bangladesh. India has called China's plans a red line. The potential for water manipulation, whether intentional or through catastrophic failure, threatens to turn a river into a geopolitical weapon straddling 2 nuclear-armed nations. Bangladesh, one of the most densely populated countries on Earth, with over 177 million people, depends on the Brahmaputra for drinking water, agriculture, and fishing. Any significant disruption to the river's flow could displace tens of millions in a country with almost nowhere left to go. China built the world's most powerful dam to control a river, but instead, it concentrated an entire nation's risk just behind a single wall. The ecology collapsed, the geology shifted, the economics became dependent on it, and the margins, they kept shrinking. Now Beijing is doing it again. Bigger, higher, in more seismically violent terrain, over a river shared by countries that already have their fingers on the trigger. We've seen this pattern before. Ambition outpacing engineering. Political urgency overriding scientific caution. A system that punishes dissent, building structures that demand honesty about risk. The Yangtze doesn't care about a 5-year plan. The Yarlung Tsangpo doesn't care about GDP targets. Rivers don't negotiate. They don't wait. They only know one direction: downhill. So what do you think? Is China engineering its future or engineering its next disaster? Let us know in the comments, and if you haven't already, subscribe to Fall of Nations, because we are just getting started.